All right, guys, welcome to Thursday's math class. This is the third class of the week. Tomorrow is Friday. We have a quiz tomorrow. We'll talk about what the quiz covers in it. Well, I'll just tell you now. It's 6.1 to 6.4. So 6.1, and we'll work one of these problems in a bit, but 6.1, if you recall, was us converting fractions to decimals, right? So like 3/5, we use long division to convert it to 0.6. We're going to practice this a bit later in class today. 6.2 was estimating, let's see here, multiplication and division with fractions and with decimals too, I believe. 6.3 was multiplication with fractions, and if you remember, and we'll say, let me find my spot here. Where was I? Here. No, not there. Here. Multiplication with fractions. Just multiply straight across. Don't have to find a common denominator, nothing like that. And then yesterday we talked about 6.4, which is division with fractions. Division is very similar to multiplication. We have to keep the first fraction, so like right here. If we have a over b divided by c over d, we keep the first fraction. A over b stays a over b. We change from division to multiplication, and then we have to flip this fraction. C over d becomes d over c, and then we just multiply straight across. So that is not new. So Chloe is at home, and I will post this lesson. I have a couple videos I didn't create. They're on YouTube that somebody else created. So I'll post that lesson, Chloe, for you to get caught up. And then also we have today where we're going to kind of like go over that a bit, starting with the homework here momentarily. And then following that, we will talk about today's new lesson. Okay, so your homework from last night was 6.4, dividing fractions. This top part, we need to name the multiplicative inverse for each rational number. For the multiplicative inverses, we need to have improper fractions. Some of these we have decimals, so like take a look at number 12. This was, well, we'll do one that's a little bit easier now. Take a look at 11 first. 11 is -8/7. All you have to do, the sign does not change. That is negative. It's going to remain negative. And then you just flip it. This is called the reciprocal, also known as the multiplicative inverse. Why is it called the multiplicative inverse? Anybody know? Pierre?
Because your inverse is like switching.
Yeah?
And then
if we multiply these two, what do we always get?
1.
We always get 1. A number, any number or fraction multiplied by its multiplicative inverse, doesn't matter what it is, the result is always 1. Doesn't matter if they're positive, doesn't matter if they're negative. A number, fraction, decimal, doesn't matter, multiplied by its multiplicative inverse, the product is always 1. All right, so that was number 11. Now number 12 is a little bit harder. 1.5, that is 1 and 1/2. So always convert these to fractions, and not only convert them to fraction, we need an improper fraction. So 1 and 1/2 is, what is an improper fraction? 3 over 2. 3 over 2. And so what would the multiplicative inverse of this be? 2 over 3. Now, do me a favor. Do not say this equals 2/3. Is 3/2 equal to 2/3? Yes or no? They're not equal to each other, right? So don't tell me they're equal. So you could either just leave a blank space, that's fine. If you want to draw an arrow, that's fine. If you want to lose a point on a test or a quiz, tell me these are equal. They're not equal. So don't say they're equal. Do not do this. No. Okay. All right, very good. Sorry. So now let's take a look at the answers from last night. If you scroll down, and Chloe, you have the answers on this too. If you scroll down, these are the answers to the top part. 7, the multiplicative inverse of that is 1/7. So you should be checking with me. Check your own work with me. If you didn't do the homework last night, please don't just write these down. 2, -1/10. 3, multiplicative inverse is 1. This is the only, well, 1 and -1 are the only numbers where the multiplicative inverse is the same as the number itself. So like -10, you flip it, right? -10 is -10 over 1, so when you flip it, you get -1 over 10. But 1 is just 1 over 1. So when you flip 1 over 1, you still have 1 over 1, which is 1. Same thing for negative 1. I can't remember if that comes up in this or not. Okay, number 4, if you change this to a fraction, you get 3/5. 3/5, when you flip it, you get 5/3. So you do have to change to a simplified fraction and then flip it. Number 5, 3. Yes, Hayes.
For number 4, I did this is not right. I just did negative.
Let's keep going on this. Number 5, can't remember if we did this already. That is 3. 3 for number 5. 6 is 5. 6 is 5. 7 is negative 12. Negative 12. 8 is 10. Any questions on that row? All right, on to the next row. Number 9. Number 9 is negative 3/4. Number 10 is 3/2. 11 is negative 7/8. We already talked about that. 12 is 2/3. We already talked about that one. On to the next row. 13. Again, the sign doesn't change, and you flip it. Negative 23/3. 14, 41/6. 15. All right, so for this one, we have a mixed number. 3 times 5 is 15. 15 plus 1 is, so we get 16/5, and then when you flip 16/5, take the reciprocal, right? We get 5/16. That's how we get 5/16 there. Ooh, no, what happened? What happened? Lost my space. Oh no. Here we are. Okay. And then number 16, we were on, I believe. There we are. Okay, 16, same idea. 3 times 4 is 12. 12 plus 3 is 15. Remember, this is going to be negative, right? Negative 15 over 4 is what that is as an improper fraction. We flip it. Please don't tell me these are equal, because they're not, and we have negative 4/15. Hey, this negative sign, where do I have to put it?
Anywhere?
You can put it anywhere. Up top, down below, in front. So negative 4/15, you could have said negative out front, 4/15. Or you could have also said 4 over negative 15. All those mean the same thing. As long as there's one negative, you can put it up top, down below, or out front. Questions on those? Okay. Now, we will definitely work some of these. Let me give you the answers first, and then you can ask your questions. So I'm going to pause the video because, Chloe, you have access to all these as well. All right, we got a question on number 26. The first thing we need to do is what here? Who knows? James?
Convert fractions to mixed numbers.
Yeah, change them to improper fractions. They're currently mixed numbers. This first one, we know it's going to be negative, right? What's 12 times 4?
48.
48. 48 plus 1 is?
49.
So that's 49/4. Divided by, what's 4 times 3?
12.
12. 12 plus 2 is?
14.
14. So check to make sure you had negative 49/4 divided by 14/3. And now we keep change flip, right? Keep the first fraction, negative 49/4. Make sure your sign makes it with you. Change the multiplication. And then we need to flip, take the reciprocal of 14/3, and that's 3/14. Okay, now as we look at this, we are looking for common factors among one term in the numerator and one term in the denominator. So what common factor do we have? Carson?
7 goes to 49.
All right, so here we go. What's 14 divided by 7?
2.
2. How about negative 49 divided by 7?
7.
Try again. Negative 49 divided by 7.
Oh.
Negative 7, yeah. Be careful, guys. You gotta check your signs. Don't let a negative sign just disappear. Anything else we can simplify here? Numerator and denominator. Any other common factors?
No.
Nope. Negative 7 times 3 is?
Negative 21.
Negative 21. And then 4 times 2 is?
8.
8. So negative 21 over 8, or if you wrote it as a mixed number, it is negative 2 5/8. Okay?
Do you want us to convert it to a mixed number?
I'll take either. You should be able to do either. So on a test or a quiz, if I say report your answer as a mixed number, rather than an improper fraction. You should be able to do that. I rarely ask for that, so I'll take either. So long as it's simplified, I'm good. What else do we have questions on? James.
I also had 27.
27. All right. We'll erase this. Okay, 27. We start out the same way. We convert to improper fractions. We know this first one's going to be negative, so let's see here. Finley, what's 5 times 7?
35.
35. What's 35 plus 2? 37. So that becomes 37 sevens. And then I'm going to go ahead and keep change flip, right? Because we've changed this to an improper fraction. I don't have to change this to an improper fraction. We're good. Change to multiplication and flip. That is going to be what when we flip there, Molly?
You would flip negative 8 to 3.
Negative 8 over 3. Very good. So now let's look for common factors. Do we have any common factors in the numerator and the denominator?
None.
Nope, we don't, right? 3 is prime. 37, we can't divide that by 3. 8, we can't divide it by 3. 7 is prime. We can't divide 8 or 37 by 7. So be careful on this. We got a negative times a negative, which is a what?
Positive.
Positive, very good. What's 7 times 3?
21.
21. 37 times 8. Now, you may not know what that is. You may not want to do it mentally. You're more than welcome to like write out multiplication like this, right? You've done this in the past. 7 times 8 is?
66.
What? I don't think it's 66.
56.
Oh, 56. Okay, 66. Create a 5. 8 times 3 is?
24.
24 plus 5 is? 29. Did I make a mistake somewhere? I don't know. 296.
Yeah, that's what I thought. Yeah, I got 296 right. Yeah.
I must have made a mistake earlier then. My bad. I don't know. 296 over 21, 14 and 2, 21st. Okay? Questions on that? Is that one we worked earlier? Like I converted it incorrectly, I guess is what happened? All right. My bad, y'all. My bad. Okay, what else do we have questions on? Oh, I see what I did. I multiplied by 20 and then added 2 rather than multiply by 21 and then added 2. That's where I messed up. Okay, sorry about that. Let's work these drill problems here. I have written one down for you as well. Let's convert this to a fraction. This will get you ready for your quiz. That's on the quiz today or tomorrow. Name the multiplicative inverse of 1 2/5, and then divide those two problems, and then work that last one down there too. So let's take about 5 minutes or so, and let's work these 5 problems. Go and do that now. All right, the first problem here, negative 7 and 3 11. So first thing I'm going to do, I know this is going to be negative 7 point something. So I'm going to write negative 7 point, and then what I'm going to do is this, a division sign. The 11, the denominator goes outside the division sign. The 3 goes underneath. Now, 11 doesn't go into 3, so what do we have to do?
Add a 0.
Yeah, 0.0, 3.0. How many times does 11 go into 30? Will?
2 times.
2 times. 11 times 2, we get 22. I'm going to put point up here and a 0, right? So wherever that decimal is, you bring it up. 30 minus 22 is? 8. We bring down our 0. How many times does 11 go into 80?
7.
7 times. What's 11 times 7?
77.
77. We subtract. What's 80 minus 77?
3.
3. We bring down our 0. How many times does 11 go into 30?
2.
2 times. What's 11 times 2?
22.
22. We subtract, and we get 8. We bring down our 0. How many times does 11 go into 80?
7.
7 times. You can see this is going to keep going on that way, right? So this pattern is going to continue. So this negative 7.27 repeating. You got to put the bar over the 2 and the 7, right? Because it's 27, 27, 27, 27. Any questions on that? Yes, Christian.
Like I didn't even realize I did this, but I did 7.2. I did 80. I turned it into an improper fraction.
Okay.
And I still got the same answer.
Yeah, if you change it to an improper fraction, you can still do it. It just is harder than it needs to be. So yeah, that's fine. But if you ever have a mixed number like this, I recommend you just take the whole number or the integer portion of it, which in this case is negative 7. Just jot it down and then figure out what 3/11 is as a decimal, and then tack it on behind the decimal. Questions there? Okay. Name the multiplicative inverse of 1 and 2/5. Well, we got to change this to an improper fraction. 1 times 5 is 5, plus 2 is 7/5. But now we have to flip it, right? And so we get 5/7. You should have had 5/7 on that. Questions there? Okay. -6 divided by, let's change this to an improper fraction. What is 1 1/2 as an improper fraction? 3/2, right? And so now we keep change flip. We keep the -6. We change to multiplication, and we flip, and we get 2/3. 2/3 there. We now multiply. Now remember, this is -6 over 1. Okay, -6 over 1. So what's -6 multiplied by 2?
No, -12.
-12 over, what's 1 times 3?
3.
3. What's -12 divided by 3?
4.
Yeah, -4. -4. Should have had -4 there.
Could you have simplified?
Did you get -4 still?
Yeah.
Yes. So if you did it a slightly different way, like maybe you simplified here first, you still should get -4. So as long as you got -4 and you supported your work somehow, I'm good with it. Let's take a look at n here. All right, on this one, keep change flip. We're going to keep the 5/12. We're going to change to multiplication, and we're going to flip or take the reciprocal, and we get 15/7. Now, we have a common factor between 12 and 15. What's the common factor between 12 and 15? Hayes?
3.
3, right? So what's 15 divided by 3?
5.
5. What's 12 divided by 3?
4.
4. Any more common factors between the numerator and the denominator?
Nope.
Nope, that's it. What's 5 times 5?
25.
25 over, what's 4 times 7?
28.
28. Now, if we did this fully on the front end, if we simplified fully on the front end correctly, we shouldn't have to simplify this, and we did simplify it fully, so 25 28 cannot be simplified, or already is simplified, I should say. There you go. Evaluate. N divided by m squared. Well, over here we see n is -2/9, so we'll write that down, -2/9. Divided by m is 1/3, and we're going to square that. Now remember your order of operations. We have to square before we divide. So I'm going to jot down -2/9. We're going to divide that by, and let's go ahead and square 1/3. Remember to square a fraction. Numerator multiplied by itself. What's 1 times 1?
1.
1. Denominator multiplied by itself. What's 3 times 3?
9.
9. So we get 1/9. Again, the way we square a fraction, numerator multiplied by itself, 1 times 1 is 1. Denominator multiplied by itself, 3 times 3 is 9. Let's keep change flip. Keep -2/9. Change to multiplication, flip, and we have 9 over 1. I noticed right away I've got 9 over 9, which is going to be 1 and 1. -2 times 1 is -2. 1 times 1 is 1, which is just -2. So there you go, -2. Molly.
For the second two undersolved, how do you know to flip the signs?
When you change, all right, so
Oh wait, never mind.
let me just remind you all, if we have 8 divided by 2, what's 8 divided by 2?
4.
4. What's 8 multiplied by 1/2?
4.
4, right? So dividing by 2 and multiplying by the reciprocal are the same thing. That's true with any fraction ever. Dividing by a number or multiplying by its reciprocal are equivalent. Jack.
If you did it for that, are you allowed to do the keep change flip first and then do the exponent?
No. I think it does work out, but you need to follow your order of operations. Yeah, square before you divide. All right. Today we're going to talk about multiplying and dividing by decimals in section 6.5. If you can multiply with 3, 4, 5-digit numbers, for example, if I asked you to multiply we're not going to do this right this second, but 525 multiplied by 72, right? And if you look at that problem, you're like, I can do that, no problem. Then you can do this today. It's pretty much this with an extra step right before it and right at the end. It's not bad. You may have done this before, but let's talk about how to do it first. Take a look at this first problem here. The first thing we do is we ask ourselves to find an estimate. So let's see, Quinn, what's a good estimate for 3.9 multiplied by 8.2? What do you want 3.9 to become?
4.
4. Multiplied by, what do you want 8.2 to become?
8.
8. What's 4 times 8, Quinn?
32.
32. So we have 32, that's our estimate. With decimals, everybody carefully listen. Carson, you listening? With decimals, we always, always, always need to estimate. It is very important. And I'll tell you why at the end. Now, Jack, how many digits do you see behind the decimal there? One. How about here? A total of? Two. 2 digits behind the decimal. So we're going to change 3.9 to 39. Everybody write down 39. And we're going to multiply that by, we're going to change 8.2 to 82. We just made both of those, like we slid our decimals over until we got integers, okay? And now we multiply. So let's see if we can't remember how to multiply. What's 2 times 9? 18. So we write an 8 here. We carry the 1. What's 2 times 3? 6 plus 1 is 7. So we get 78, right? Now, in the ones place, I need to write a 0. So we put a 0 there. What's 8 times 9? 72. So we write a 2 there. We carry our 7. What's 8 multiplied by 3? 24. What's 24 plus 7? 31. And then what do we do with these two? Add, right? Okay, so now let's add. What's 8 plus 0? 8. What's 7 plus 2? 9. And then 31. Okay, so now let's take that number, 3,198, write it off to the side just like that. Now you remember a moment ago, Jack told us how many places were there behind the decimal?
2.
Total of 2, right? So here's what we do. We take our decimal and we slide it however many places there are behind the decimal. Jack told us there's 2, so we slide it 1, 2 places, and right there is where our decimal goes, 31.98. Now, is 31.98 close to our estimate of 32?
Yes.
It is. Let's say you forgot to do that part, and you told me the answer was 3,198. Look at your estimate, 32. Are these two numbers close at all?
No.
They are not. Let's say you moved it too far, and you said it was 3.198. You can then, the reason your estimate is so important is because at the very end here, if you just glance over here and say, am I pretty close to my estimate? If the answer is no, you probably put the decimal in the wrong spot. Check and double check to make sure. 1, 2 spots behind, or 1, 2 digits behind the decimal. So we got to slide it in 1, 2, right there, 31.98. Hayes. Sure. Okay, with this next one here, who have I not talked to today? Connell. On this problem, what do you want negative 6.302 to be? Negative 6. Let's make that negative 6, everybody. Oh, negative 6. Why is that happening? And we're going to multiply by, what do you want 0.81 to be?
0. Oh, sorry, 1.
Let's make it 1. What's negative 6 times 1, Connolly?
-6.
Negative 6. So there's your estimate. Now, everybody on your own, see if you can do this next step, and then the final answer, see if you can get it right. I'm going to pause the video now, so Claire, you try this too. Look. So here we go. Negative 6.302 multiplied by 0.81. I'm just going to keep in mind this is going to be negative at the end. We'll talk about that in a second. 1 times 2 is 2. 1 times 0 is 0. 1 times 3 is 3. 1 times 6 is 6. Put down a 0. 8 times 2 is 16. Carry the 1. 8 times 0 is 0. 0 plus 1 is 1. 8 multiplied by 3 is 24. So I write a 4 here in the 1 place. Carry my 2. 8 multiplied by 6 was 48, right? 48 plus 2 is 50. Everybody good with that so far? And now we add. 2 plus 0 is 2. 0 plus 6 is 6. 3 plus 1 is 4. 6 plus 4 is 10. Carry the 1. 1 plus 0 is 1. And then 5. So now I'm going to jot down 5. Let me do some blue. 510462. Connolly told us there's how many places behind the decimal? 5. 1, 2, 3, 4, 5. 5 places behind the decimal. So I've got to take my decimal, I got to slide it in. 1, 2, 3, 4, 5. 5.10462. Is that close to my estimate of negative 6?
No.
Where did I go wrong?
No negative.
should be negative. Do not tell me this is negative, right? Because we multiplied a positive times a positive, we should get a positive product. All you have to do in your final answer, just slide a negative in. I can guarantee you this is going to happen to maybe all of you, but a lot of you. You're going to forget that this was negative, and you're going to forget to slide the negative in. But if you go back and just glance at your estimate, you're going to remember to put it in. All right? Now, is negative 5.10462 close to our estimate of negative 6? Yes or no? It is. So that's your answer. Will, you had a question?
No, I was just,
Wait, hang on a second. Sorry about that, Claire. All right, here we go. Our estimate here is negative 2 times negative 2, which is positive 4. There's 2 digits behind the decimal. So negative 2.3, I just made it 23. Negative 1.9, I just made that 19. So 3 times 9 is 27, so 7 here, carry the 2. 9 times 2 is 18. 18 plus 2 is 20. So we get 207, 0. All right, let me erase the 2 that I carried. 1 times 3 is 3. 1 multiplied by 2 is 2. We then add, and I get 7, 3, 4. So that's going to be 4. Let me do this in blue. 4, 3, 7. And we said there was how many digits behind the decimal? 2. So we put decimal there, and we get 4.37. Any questions or issues with that at all? All right, good. This next one here. Okay, now, you probably said this is going to be 0, right? You said this is going to be 0, and you also said this is going to be 0. And what's 0 times 0? 0. But notice the signs. What's a negative times a positive?
Negative.
A negative. So I'm going to write negative 0 for my estimate. I know there is no such thing as like negative 0, but I'm doing that for our sake so we understand that my final product needs to be negative. It's going to be a number very close to 0, but it's going to be negative. We've got 1, 2, 3, 4, 5, 6 digits behind the decimal. So 2, 6, 4 multiplied by, if you made it 0, 2, 5, that's fine. You don't have to. I'm just going to write 25. 25. Okay, boom. You get the same answer either way. 5 times 4, we get 20, so 0 there. Carry the 2. 5 multiplied by 6 is 30. 30 plus 2 is 32. Carry the 3. 5 multiplied by 2 is 10. 10 plus 3 is 13. So you get 1,320. 0 there. Let me erase this. 2 times 4, we get 8. 2 times 6, we get 12. So 2, carry the 1. 2 multiplied by 2, we get 4. Plus 1 is 5. Any issues there? 5,280. 0 plus 0 is 0. 2 plus 8 is 10. Carry the 1. 1 plus 3 is 4. 4 plus 2, 6. 1 plus 5 is 6. So we have, let me do this in red, 6, 6, 0, 0. Now, how many digits were behind the decimal? 6. So we got to take our decimal and go 1, 2, 3, 4, 5, 6. So point here, 0, 0. Do you have to have these 0 zeros on the end?
No.
No, you do not. So I'm going to erase these 2 zeros on the right because it's the same thing as that. Now, am I done? Remember, it's got to be what?
Negative.
Negative. Negative 0.0066. Questions on that? That was a little tough toward the end there. Okay, your homework is from the book tonight. It's only 6 problems. I think I just sent it your way. Let me double check. I did. Book pages 298, numbers 18 through 23. That's a total of 6 problems. You must show supporting work to receive credit. No work equals no credit. Feel free to check your answers with a calculator. I need to see supporting work. I know you can use a calculator, so if you don't show supporting work, you're not going to get credit. Hope you have a great day. Thanks for watching there, Chloe.